Hi, here's the result. And here's the Typst code. You can find all the necessary materials in the description. We start out by creating a title and a subtitle, then add their own images. To add the interactive overlays, we first import the sets package, which enables us to define a canvas we can then draw on. You can always visit Typst Universe to make sure you've got the latest package version. In fact, you can copy the import commands straight from there. So we use the canvas as shown in the provided code snippet. From there, we import content because, as you see, we cannot use image alone inside Canvas. We do not import everything at once inside the canvas, as you might have noticed in the code snippet, simply because anything we do not need has a potential to clash with the existing definitions for rect, scale, and many more. Now we wrap our image and content at coordinates 0, 0. The image may very well be too big for our needs, which is why we scale it down. By also enabling the reflow option, we remove the white space left over from scaling the image. Next comes the overlay, in our case a square, more generally speaking a rectangle. Here, the Typst built-in rect function is used, and therefore wrapped in content. If we wanted to use the shapes imported from sets.draw, it would be easier to specify their position and size, but I feel like hyperlinking them after would become a problem, because we would somehow have to wrap them with a link, and that again would have to be wrapped in content. Instead of the rect that we're currently using, it's completely fine to also use block or box, but I mainly prefer rect here, because it comes with a default stroke before we decide to replace it with a fill. You may have noticed the magic numbers put in the coordinate and dimension slots along with scaling we're using. Understandably, this is the only manual input, which also takes up quite a bit of time, but the scaling we put next to all four of those numbers means that it will then always match the image, no matter its size. We decorate the made rectangle with a mostly transparent fill and a title. Furthermore, we probably want the title to be centered both horizontally and vertically. On top of that, we give it a scalable small cap style. With this, we have an overlay whose purpose so far is purely visual. Making it interactive is only a step away, the step being link function. Among other things, the link can lead to a website. Because we want to use it for jump into a certain room of the floor plan, utilizing labels is a reasonable choice. One way of writing labels is with these angle brackets. Once we wrap the rectangle in link as well as point it to a label, our goal is essentially complete. Despite it being done, there are many room overlays to be individually positioned. And as it stands, we would end up with unnecessarily long code. In order to recycle most of the written code when adding new overlays to the floor plan, we make use of functions. Let's build our way up from the smallest parts. For example, we can have the ratio of 90% be globally defined as a variable under the name floor plan scale. We might as well extract out the line describing the image, give it a similar name, and convert it into its own function. Both the scaling factor and the image are now variable. All that's left to cut and paste is the overlay. Again, we convert it into a function that accepts whatever we think is worthy of customization. Most likely that would be the shape's X and Y position, the shape's width and height, the font size, the shape's transparency, the shape's color, our target's label, the shape used, and the text which best represents our overlay. You probably want to choose less ambiguous argument names for yourself. Then we replace all currently fixed values with their respective arguments. This includes replacing the fixed scaling factor, as was the case in our floor plan image function. Just be careful about the units matching up, hence the division with 1%. As we start including our newly made pair of functions into the canvas, we met with an error message about content being unrecognized. To get rid of it, we need to prepend sets.draw to content. What happened was that we decided to move content outside Canvas, but the only location where content is imported is inside Canvas. Furthermore, we can delete the import of content because it's now explicitly prepended everywhere we use it. Continuing on, the overlay can be edited along with all the fixed values which were previously cemented into the much larger piece of code. It might not seem like we did much by creating our own functions, but to demonstrate the power of the room overlay function, we can simply create another subtitle, equipped with an image and a label. We add its entry for room overlay inside Canvas with its unique set of fixed values. This time we choose a green color to fill in the shape of an ellipse. Notice how the second interactive overlay has been added with very minimal effort. On top of that, it turns out we didn't even need to manually type out the text this whole time. Instead, we query the title via a label that it's tied with. Lastly, here's proof that different scaling doesn't ruin a single thing. To further expand on the drawing capabilities of this implementation, feel free to use the polygon function. In that case, the room overlay function would take a single array of any length instead of the width-height arguments that we currently have defining our shape size. However, you have to be careful with the Z order in which you place these polygons due to the selectable hyperlink area still being rectangular. In fact, it's already a problem when using oval shapes. I found no way around this yet, unfortunately, not even clipping helped. If you do not require dynamic scaling of content as shown, you could probably also use the place function without any mention of sets. I assume it's possible to achieve the same with just the place function in a way I hadn't thought of. All this can similarly be done in LaTeX with ticks, specifically by putting the image as a node inside a tick-rich environment, then drawing on top of it. Possible future changes coming from activity in a currently related GitHub issue include the addition of an overlay function. So despite having shown you a fairly useful way of implementing interactive overlays, I would be on the lookout for potential incoming shorthands.